Yep. Momentum would be a good topic for our project. We're not doing a video on momentum. Our video is on conservation of energy.
'Cause every time we touch, I get this feeling, and every time we kiss, I swear I could fly. Can't you feel my heart beat fast? I want this to last. Need you by my side. 'Cause every time we touch, I feel the static, and every time we kiss, I reach for the sky. Can't you hear my heart beat so? I can't let you go. Want you in my life.
Dad's home! Dad!
Hey boys,
We missed you.
what'd you learn at school today?
Today we learned about physics.
Physics. So guys, what type of physics did you learn about today?
We learned about energy.
Well, son, what type of energy did you learn about?
Well, we learned about two types of energy. We learned about potential energy.
And kinetic energy.
Well, what exactly did you learn about them?
We learned that potential energy is energy stored within an object, similar to if I lifted up a ball 5 meters above the ground level. It would have potential energy because it has the potential to fall down off that 5-meter height.
We also learned that kinetic energy is the energy of an object in motion, where if I was running at 5 million meters per second, then I would have a large amount of kinetic energy.
So what else do you guys need to know?
Well, Papa, we don't know how to solve for these.
Well, that's where I can help. I think I have a marker somewhere. Potential, also known as PE, potential energy. Here's the equation, also known as PE. The equation, mgh. Mass times the acceleration due to gravity times the height. How high off the ground? Kinetic energy. You want to know how much energy you have? Alright, buddy. KE equals 1/2 mv squared. M being mass, v being velocity in meters per second. Anything else?
But Father, how do potential energies and kinetic energies relate?
Actually, sons, both of you, what you gotta realize is they do relate. It's actually a phenomenon. KE, kinetic energy, plus PE, potential energy, equals total energy of the system. Thanks for your attention.
So, right now, I have 0 energy. I am at ground level, negating my potential energy, and I have no velocity, negating my kinetic. As I bring myself up, I gain potential energy, in that I am still at rest, but I now have added height to the equation. And as I bring myself down, I have velocity, so I have kinetic energy, combined with potential energy, in that I am moving and am still above ground level. Let me show you again. Potential energy, kinetic potential, kinetic potential, kinetic potential, zero energy.
As we're climbing the hill, we're gaining potential energy as we are gaining height or away from ground level. So we're gaining potential energy. When we hit the crest of the hill, we're gonna make kinetic energy. Ready? Potential! Woo! Woo! Potential kinetic, potential kinetic, potential kinetic, potential kinetic, losing potential kinetic, losing potential, losing potential, gaining kinetic, losing potential, gaining kinetic, gaining potential, losing kinetic. The rain is like stars hitting the. Getting kinetic! Losing potential! Gaining potential! Losing kinetic! Gaining kinetic! Losing potential! Gaining potential! Losing kinetic! Gaining kinetic! Losing potential! Gaining potential! Losing kinetic! Tunnel! Tunnel! That was insane to remember. Wow. So we saw potential and kinetic G on the physics video series ride.
Okay, as you can see, we are building up height. We are oscillating back and forth. We are not yet to our maximum height. But when we do reach our maximum height, we'll have the most potential energy at the highest point, mgh. With m and g remaining constant, the height will multiply to reach our greatest potential energy. As we lower to be right here at the bottom of the oscillation, we'll have the most kinetic energy as we receive energy as we fall in free fall. The formula for kinetic energy is 1/2 mv squared. With the mass remaining constant, the velocity increases. Hey, over here! As the velocity increases, as we go down, we receive the most at the bottom. We have zero kinetic energy at the top, which is why we turn into a free fall towards the bottom. As we go through the ride, the time difference, or the potential energy decreases as kinetic energy increases. Now, as we slow down, we will lose potential energy at each maximum, and we'll also lose kinetic energy because of this, as potential energy plus kinetic energy equals energy total.
Window. I'm really wondering what's gonna happen when we throw the cat out the window in the box.
Dude, it'll probably just blow up.
Well, do you really want to kill your cat?
No, dude, but for the physics video, it might be worth it.
Oh, that's true. Let's try it.
Seriously. Alright, so what happens if you put a cat in a box? Come here, Lulu. Good kitty. Now, we'll cover this box. Okay, so now, what happens if we give this box and the cat potential energy?
Uh-oh.
And now we'll give this box kinetic energy. What happened to the cat?
Is the cat dead or alive?
Is the cat still in the box, or is it under the blanket?
That's a mystery that we will solve.
So, now I've concluded, the cat is not in the box or underneath the blanket. So according to the laws of physics, when you throw a cat out a window from a second story with potential energy, you give it kinetic energy by throwing it down, the cat is annihilated and no longer alive, dead, or even here right now.
I found a pencil, so we're good with that.
Excuse me. This is a female. We're gonna ask her perspective on physics. What do you think physics is?
Nobody should ever take class.
Alright, so that's why we don't ask women perspective.
Okay. Well, we learned about two types of energy. there's potential.
Well, we learned that potential energy is. We learned that potential energy. I can't do it anymore.
For Mike now.
Well, son, you gotta realize no one can run that fast.
I feel like we should take our shirts off now.
I feel like it's only right. I wonder if he's gonna be mad about the whole we're not wearing a shirt.
P E equals M G little g H. M stands for mass. G stands for the gravitational constant, which is 9.8 meters per second squared. H is the height, how high off the ground you are.
Oh, excuse me.
Kinetic energy.
Mike, I'm going to tell you right now,
It's not the gravity.
it's not the gravitational constant.
It's just gravity.
That's big G.
And you farted, so.
Blooper in there. The fart is definitely going to be a blooper.
How about do they equal each other? Say, well, in any equation, PE equals KE.
Actually, what's unknown to most human beings is a phenomenon. They equal each other. They're completely the same, but yet different.
Ready?
So what am I saying now?
Same thing.
You just gotta get a shot out the window.
Stop. You can't go back in the box yet. No, stop. Jesus.
Why don't you just hold it in the air so I can...
Oh, you're kidding.
Not the cat.
Oh.
The box.
I just gotta come from behind the bush.
That kid just came from behind a bush.
Dude, no way.
Oh my god.
Oh my god.
Is he just taking a jog? Speed up?
Dude, this guy's running at speed. Oh, he's taking his shirt off.
Shirt off, what? Let's get him.
What?
Yes.
Bye. Have a beautiful time.
I know what that means.